Well, thanks everybody for joining me here on day 3. It's good to see you all here. So my name is Nate Schutta. Best way to describe me these days is architect as a service. Someone called me that last year, so I've been kind of using that as my proverbial title, I guess. And I did think that was a compliment, actually, when someone called me that, until I sounded the acronym out in my head and realized it may not actually have been intended that way. But let's talk about the cloud, shall we? So there's a lot of different options here. And for better or worse, a lot of developers think the cloud means I have to do microservices. And so a lot of people today are dusting off their copy of domain-driven design, and they're searching high and low for bounded contexts, and maybe they're even breaking out a ubiquitous language. They're figuring out what a two-pizza team is, and that's good, but I think there's a step we missed, which, to paraphrase everyone's favorite chaos mathematician, your developers were so preoccupied with whether they could, they didn't stop to think if they should. And we're starting to see some pain come out of that. There's a decent chance your call structure might look a little something like this. You know, there's a reason this is referred to as the Death Star architecture. You know, that's no moon. And we're realizing, wow, this is actually harder than I thought it was going to be. I was under the impression that microservices were going to solve all my problems. Now, there are a lot of good reasons to use microservices, and I'll talk about those here today, but it's vitally important that we understand there are no free lunches. There's no point in us adding this complexity to our systems if we're not getting any benefit for it. And I've seen lots of people go down the wrong path, and now all of a sudden they've got a substantial amount of accidental complexity in their system. And honestly, what we're doing is hard enough. We don't need to make it more difficult. And so I think it's important for us to take a step back and ask ourselves, when should we consider microservices? So last year, I wrote this series. It started as one entry, and then my editor's like, no, we need you to write more, and so I kept writing about it. This actually came out of work that Matt Stein and I did with a customer, and it was one of those things. We were in a room for 3 days, and we were kind of spinning our wheels until Matt wrote these principles up on the board, and it made the conversation so much more productive. And so that's what I'm going to share with you guys today. Now, we'll start with just sort of a basic, what do we even mean by microservices? Because there's still an awful lot of confusion about what that even means. Now, this is fundamentally a reaction to the heavyweight services that many of us wrote a few years ago, and of course, what cloud environments give us. Now, if you've been in our industry long enough, you're well aware of the fact that monoliths hurt. Your productivity on a ginormous code base is generally not great. It takes a long time to get your head wrapped around that. I worked at one place where the expectation was it was about a year before you truly were comfortable in the code. That's a long time to wait from both sides, as a developer trying to be productive, and certainly on the other side of the coin trying to get productive work out of people. So these long ramp-up times aren't great. And of course, on the monolith, I'd make one small change and I have to deploy everything, and that always is a little bit scary. I remember having this debate with one of my test leads, and she told me, Nate, we can't do that because it's an 80-hour run of the regression test suite, and I'm just not willing to do that again. If I needed to scale, I couldn't just scale up the part of the application that needed it. I was stuck scaling the entire thing. It was difficult to evolve. Now, every one of you at some point has learned about the second law of thermodynamics. This is typically referred to in my world as the teenager's bedroom. The universe wants to be disordered. And of course, software is not immune from that. Every one of you at some point started on a project and uttered something along the lines of, this time we're going to do it right. And then 6 months later, you're like, where did we go wrong? How did we end up here again? Well, we're fighting against nature, essentially. So modularity breaks down. It takes longer and longer to add new functionality. And this frustration, again, combined with what the cloud gives us, sort of birthed this new style of the microservice. Now, of course, there's no one definition. This is the very epitome of you'll know it when you see it. And of course, we love to argue about terms, don't we? So this is my boss who wants to argue about the definition of made-up words with me. This is one of my all-time favorite tweets. I'm partial to any definition that reminds people these are small. And so I've typically relied on something we can rewrite in 2 weeks or less. I know a lot of people are very fixated on this whole two-pizza thing, and I find this to be not great on multiple sort of planes. I mean, first of all, well, how big is the pizza? Right? If it's a small pizza, it's not going to feed as many people. It's also important to ask yourself, well, when are we having this pizza show up? Because, right now, well, I suppose by the end of this talk, if I put a pizza up front here, you guys would all probably be pretty hungry. It might disappear pretty fast. I put that same pizza down right after you had lunch, you might not eat much of it. The real problem, though, with the two pizza team definition is something that my director came to me with at my last org, and he said, listen, Nate, I need advice on how many services these two pizza teams can handle. And of course, all I could do is sort of shrug, say it depends. Because if those services are really volatile and they're changing all the time, that two pizza team might only be able to handle a handful, 3, 4, 5. If those services are very stable and they've been around for a while and they're not changing as rapidly, that exact same two pizza team might be able to handle 20 of them. So I think it's important to think in terms of characteristics. These are small, focused services. They do one thing. They do it very well. It's sort of that Linux, Unix model of you take a series of simple tools, you pipe them together to get more complicated results. They should be independently deployable, independently scalable. They should be able to evolve at different rates. They should give you the freedom to choose the right technologies for the job. They should fundamentally be built around business capabilities. They are, in a nutshell, high cohesion, low coupling applied to services. Now, the longer I do this, the more convinced I am that high cohesion, low coupling is like the zeroth law of software engineering. The moral of the story, it's just an approach, a style, a pattern. It is not the golden hammer that's going to solve every problem you've ever had, despite what some people may have tried to tell you. At the end of the day, they are a tool. That's it. It is on us to use them where it makes sense. That is the challenge for all of us, is to use them wisely. Now, it's important to understand that we're not required to do microservices these days, and they're not always easier. So my friend Simon Brown likes to say, if you can't handle a monolith, what makes you think a microservice is going to somehow be better? One of his twists on this is, if you can't handle a big ball of mud, what makes you think a distributed big ball of mud is somehow going to be simpler? So sometimes the right answer here really is a modular monolith. Well, let's talk about some of the reasons where you might want to use a microservice, where this actually makes sense. So the first thing to look at is multiple rates of change. There's a pretty good chance somewhere on your system you have a part that is changing all the time, and you have other parts that, quite frankly, haven't changed since the initial commit. So when you find yourself in a situation where some part of the system is evolving at a rapidly different pace than something else, this is a pretty decent reason to use a microservice. So let's imagine a hypothetical shopping system kind of thing. Looks a little bit something like this. We've got the typical things you would find in sort of a retail operation, a recommendation engine, search, inventory. Pretty good chance your cart hasn't changed a lot. You add items, you remove items, you change the quantity of items. The inventory system, you might not have any choice here. It might plug into some 20-year-old warehouse system that you have no control over. But I've yet to see anybody say recommendations are good enough and, search is just too good. Everybody always is trying to improve this. So in a traditional monolith, we're kind of stuck. Everything has to evolve at the same rate. And this is fundamentally why we've had this quarterly release in our past, because it made sense to wait until all the changes were done. And we got to push the whole thing anyway, so you might as well just batch those up. Now, I always thought that was kind of ironic, because you've all at some point in your career probably been locked in a windowless conference room that had some term like war room associated with it because, we had a big bang, integration this weekend and it went poorly. Who could have possibly predicted this? And we, only put 1,500 changes in, so let's try to figure out what was the cause of the break. If I put in one change and it broke, that's really easy to figure out what change caused the problem. Now, of course, today we actually have options. I can split the system up, and so I can iterate parts of the system more rapidly than others. So I might take that widget I/O system, I might break it apart, and I might say, the recommendation engine, we're going to make that a microservice. We're going to make search its own microservice, so they can evolve at a different rate than the rest of the system. And now I can turn around changes more rapidly. I can deliver business value more quickly. Now, the next question, of course, is how do I know which components need that? Well, let's be honest. You probably have a sense of this in your own systems. So trust your gut instincts. But let's remember, data can be really helpful. So we can start with something simple. You can start with source code management. You're probably using Git. You might be using Git. There's a chance you're using Git. I just saw a tweet this morning that said, face it, if you've used Subversion, and I can't remember the other tool, another source code management tool, you're old. And I thought, oh, well, I guess, that's how it works in this industry, right? But I can take my source code management tool and I can essentially get a heat map out of it that can give me a sense of what's changing a lot. So, again, if I'm using Git, I can throw a command kind of like this at it, and I can sort of get some interesting data. And I ran this against Spring a while ago, which is not, a monolith, but it makes for a good teaching example. And not surprisingly, there's certain things that are changing all the time. And some of that makes sense. You look at it, well, the change log changes a lot. Shocking. But then you start looking and you're like, I wonder what these other files, what's happening there? And I'm not an expert on the nitty-gritty of Spring, so I don't know necessarily how to interpret this, but it at least gives you a place to start. And now we can sort of roll up our sleeves and we can practice a little software archaeology. A lot of times that's what we're doing. Have you ever been digging through some code and you're looking at it and you're thinking to yourself, like, what idiot wrote this? And then it occurs to you that it was you from like 6 months ago? You're like, oops. So we need to dig around a little bit and to paraphrase Isaac Newton, look for some smoother pebbles and some prettier shells, or what Michael Feathers calls churn. Now, Michael wrote this around refactoring. Where should we find things to refactor? And so inevitably on almost every project, you're going to find this sort of long tail distribution. You've got some files that are updated all the time, and then it sort of tails off to things that probably haven't been touched since that initial commit. Now, Chad Fowler took this same idea and said, I can create a tool called Turbulence that's based on churn versus complexity. You can also look at basic code forensic tools. So I have not used this in anger, but I was doing a little searching and found this and thought it was kind of interesting. And you get a view into your code. And so you start to get a sense of, how many lines do we have, how long has it been since something was touched, and it really breaks down into the individual modules quite nicely to tell you where there might be certain hotspots. And so you can start to look at some of these and you start to get some interesting data. We can look at trends over time. We can see that, all right, so this is a pretty small file, 810, 811 lines. That seems about right. We do have one person who's done an awful lot of the work here. There's been a decent number of bug fixes in here, and clearly it gets modified a lot. We get kind of this rough complexity trend. Things are getting better over time. Clearly a couple interesting little spikes in there. That might be sort of an interesting historical thing to look at. We can look at something as basic as cyclomatic complexity. There's a couple numbers there that would worry me. 44 gets my attention. The worst cyclomatic complexity I've ever seen in code that I had to touch was 82. I still to this day cannot understand how someone sat down and wrote something that was that hard to get your head wrapped around, but they did. So we can also see trend lines. Trend lines are actually one of the most useful things for us to look at. Are we getting better or worse over time? The raw number might not be nearly as interesting as what our trend looks like. So we can get all sorts of interesting views into how our system works, who's working on that system, where is that coming from. We can also start looking for those single points of responsibility. Do we have anything where there's only one person who really knows it well? Some people refer to this as their bus number. What would happen if that person got hit by a bus? I try to think about it more positively. I think, what would happen if that person won the lottery tomorrow? So you look and you see that there's, this Mr. Crosby person has certainly been doing an awful lot of work in there. A lot of these files, he might be the only one that really understands it. And that's kind of a dangerous place to be. I was working at one company, and we were sitting in a room talking about some defect, and someone literally paused and said, "Oh, no one goes into that part of the code base. It is strong with the dark side of the force." I thought, that's not a great place to be. That's kind of scary. Now, you don't have to use a tool like this. Again, your source code management tool can give you a lot of data. You can even look just simply as, when was the last commit on GitHub? If it was the last time we had one of those crazy super blue blood moon eclipses, well, that's probably not a good candidate for a microservice. If we find these things that are changing all the time, that's where we want to start doing some deeper investigation. Don't be afraid to use your bug tracker. There's a pretty good chance defect density is going to lead you towards this as well. Don't be afraid to look at your backlog. Where is all the attention being spent? Now that's cool. We've identified some things that might make sense, but what do we do now? How do we pull it apart without destroying the world? Well, this is where the Strangler pattern comes to play. This has been around a long time. I actually was amazed when I saw this tweet and realized it's really already been 10 years. That makes me start to feel really old. You realize how long these things are around. But the Strangler pattern, which is something that Martin's written about for a while now, says, instead of trying to replace the whole thing at once, these big bang replacements, just build around the edges. and you gradually replace those heritage bits over time, which greatly reduces the risk of that big bang cutover. I've been a part of a lot of those projects in my career where we've done the big bang replacement, and it's always painful because you're inevitably going back to your customers and they're asking you, when is it going to be done? And we're in this sort of almost perpetual, hey, we're like 90% done. 90% done, we're almost done, and we're there for like a year before we finally give it to them because we all just kind of give up. It's much better for us to incrementally deliver, to show business value on a regular basis, to show progress on a regular basis. Now, we can take that a step further and apply data to that. Because let's be honest, every time I've ever done one of these replacement projects, someone will ask, like, what are the requirements? And everyone just kind of shrugs their shoulder and says, nobody actually knows how the old system works. And on half of these, what I've been told is it needs to work exactly like the old system, only better. So there's a pretty good chance we don't understand all the nuance of the old system, which means as we do these conversions, we inevitably introduce defects. What if we actually had real-world data about what the system does? And that's this notion of taking Strangler a step further and applying data to the process, the data-driven Strangler pattern. So this was originally done on, I think it was a pricing algorithm, and nobody quite understood what the old pricing algorithm did. So step one, put a proxy layer in between, and for a while, however long you need to go to understand the system, you just log the results. They give me this, I give them that. Rinse, repeat. We now know what the old system does. We can now start to build test cases about what we expect to have happen. So it literally looks something like this. Now, as we build that new microservice, once we feel comfortable that, yes, we think we've covered all of those old cases, we can now run both of them in parallel. And we can send the request to both the old and the new. And we get the results back and we compare. We say, all right, did we get the same result? Awesome. That means we're good. We return the result. And if not, well, we'll go with the heritage result for now, but we're going to log that out, and we're going to ask a human being to investigate to see why they didn't match. Right? And so there's a decent chance, ironically enough, that the old system is wrong. That has happened before, will happen again. So this is one of the most important reasons to consider using microservices. We also want to consider independent life cycles. Monoliths are big ships. They do not turn on a dime. I spent a lot of my career in big enterprise companies where I've heard this repeated phrasing of, Nate, we don't turn quickly. We're a big ship. It takes us a long time to turn. And my response to that's always been that we should probably start turning now, right? And there's no point waiting a year and then deciding to turn. We just don't have that luxury today. Today we have to always be changing. We have to run experiments. We have to do A/B tests. We have to be much more responsive to the changes that are happening in our business environment. I have to deliver in days, not months. So at Spring One a couple years ago, a person from Scotiabank got up and talked about how, yes, we used to do quarterly releases, and now we do thousands of releases a month. Now, that didn't happen overnight. That takes time. That takes years. That takes a lot of discipline, a lot of engineering change, a lot of culture change. And what was really interesting to me is I had some friends that were at the company I used to work at were there, and we were talking about this one day, and they said, Nate, we can't ever do this. There's no way. And my response was, yeah, you can. If a nearly 100-year-old bank can make these changes, so can you. You just have to be ready and willing to do that. Because honestly, today we have to move faster. Look around. Disruption is impacting every single business. No industry is immune from that anymore. So if we go back to our widget IO monolith, let's assume our business partners have identified a new opportunity, but we have to get something out in the market now. We can't afford to wait. The quarterly release cycle is just not going to do it. Well, we can build that as its own standalone microservice, the Project X microservice. And so it is independent of everything else. It can have its own repository. It can have its own build pipeline. It can have a completely independent life cycle. So that's definitely a win. We can get to market faster. It increases developer productivity. Every one of you has started on a project and been presented with this 87-page getting started guide. And ironically enough, there's always a manual step where it's you have to go talk to Kathy now, and then Kathy will finish setting up your IDE for you because there's some weird thing. I was actually baked into somebody's getting started guide for 3 years. I had started on the project, and then I had left it. And once I left, I didn't have rights to change anything on the project anymore, so I didn't get a chance to remove my name. And so I kept getting these random calls Be like, hey, yeah, I'm on like step 15 and it says I'm supposed to call you. And then I try to help him. And the only way I finally got out of it is a friend of mine went onto the project and he called me and he's very incredulous. He's like, why the heck am I calling you? You haven't been on this for like 2.5 years. I'm like, I know, but I can't take my name out of it. And he says, do you want me to do that? I said, yes, please. And he took my name out and I stopped getting phone calls. It was amazing. I've seen projects where the build time was almost measured by phases of the moon. It's like, yep, it's going to take 24 hours if we're lucky. I've seen instances where getting up to speed was a months-long process. And we have to think about that. The long stretch here to being productive is not good for any of us. If I have a smaller scope, much easier to get my head wrapped around that. Smaller scope, my builds are going to be fast. When we break the build, we fix it quickly. It can be much simpler to test in these environments. I'm not stuck with that 80-hour manual regression test suite anymore. I can have a bunch of fine-grained tests that run on every commit. I can maybe have performance running all the time. I can use the right tools for the job. If I'm in a shared life cycle, I'm at the mercy of whatever the longest, slowest moving part of this happens to be. I'm not stuck in a one-size-fits-all approach anymore. Every microservice can use the mix of tests that make sense for it. They can use the right linting rules. They can use the right code quality scans. It can make finding fitness functions much, much simpler. I can actually practice hypothesis-driven development. Predicting for the future is impossible. This is one of my favorite quotes. Prediction is very difficult, especially if it's about the future. And yet every one of us has engaged in this. Every one of us has been in the project room, and we've had this debate over something. If we do it this way, it will clearly increase sales or increase conversions or increase signups or whatever metric we care about. But how do you know? You don't. I mean, you're just trusting your gut instinct. And of course, we have to ask ourselves, well, what happens if we're wrong? If we were in the monolith, we by definition had to be very conservative, because if we were wrong about something, we basically had to wait another 3 months to fix it. So we couldn't do these experiments very easily. Well, we can now. We can actually do A/B testing. For so many years, this was really just the purview of giant technology companies. It was beyond the reach of most of us. Now, technology has made this so much simpler to spin up multiple instances. But we can finally practice hypothesis-driven development. Instead of having this debate in the project room, we can actually say, all right, we think this change will result in this outcome. We will know we have succeeded when this metric changes. So we can say, we think adding a distributed cache is going to result in faster startup times. We will know if that's the case if startup times are less than 15 seconds. This can give us some really interesting fitness functions. This allows us to do some of these experiments that, again, used to only be the place of Googles and Amazons and things like that. We can all do it today. And let's be honest, every single one of our customers wants a constantly improving product. Now, this doesn't happen overnight. This doesn't happen easily. This requires some discipline to make it happen. And we have to use paved roads to get that done. You know, one of the things we'll talk about here in a minute is this polyglot notion. Everyone's very excited about that with microservices. But we have to understand that even at companies that really have this as part of their culture to give developers autonomy, there are trade-offs to that, which says, you know what, we have well-worn paths. We know how this works. We know how to support it. We have proof that this works. Repeatedly, we've done this. We urge you to use the well-worn path. If you choose to take the minimum maintenance road, you are on your own. We cannot guarantee any outcomes. This is the other side of this coin that a lot of developers haven't quite grasped yet. If you want to go down that path that no one else has tried before, you build it, you own it. You are accountable. You are responsible. Now, let's be brutally honest. The only way we get better at something is repetition. If you only do something once a year or once every other year, you're not going to get very good at it. This, to me, was one of the problems we've had with these quarterly releases. We never improved because we did them so rarely. And most of us would walk out of these war rooms going, I don't ever want to experience that again. But I don't have to worry about it because, the next release is a few months away. And then we get right back into that same point. And we're like, God, don't we know this sucks? Yes, but, what are you going to do? The moral of the story is we need to deploy early and deploy often. That is the only way we get better at this. It is the only way that we establish trust and faith in the process. So we have to have robust pipelines. We have to take advantage of all these tools that we have at our disposal. Now, it's not trivial to create a pipeline. If you're not sure what to do, start with Spring Cloud pipelines. This gives you a starting point that you can then customize to your heart's content. And it's an opinionated approach to sort of this build, test, stage, prod workflow. It's not going to try to own your build, but it gives you a sense of here's a good place to start, now customize. I'm very much of the opinion this is one of the most underappreciated benefits of microservices. And the other side effect of this is we have to get out of this mindset of that's how we've always done it. These are some of the most dangerous words to utter in an organization these days. And it's really unfortunate. I was working with somebody last year, and they were walking me through their architecture, and part of their issue was, for our overnight batch run is taking longer and longer and longer and longer. And so they said, yep, for every set of widgets, we process each widget, and then we do some aggregation at the end. And so I asked, just a question for someone who's never experienced this before. I don't know their environment. I don't know their code. I said, well, do you have to process each widget sequentially? Do the results of processing widget 1 feed into widget 2, feed into widget 3, feed into widget 4? Oh, no, it's just at the end we have to aggregate stuff together. So you could process them in parallel? And light bulb goes off. Oh, yeah, we never thought of that. Now, I'm not trying to say that I'm somehow had some brilliant insight, but I didn't have that sort of legacy, that's how we've always done it viewpoint. And that's one of the benefits of my job is I get to kind of show up and ask some of these impertinent questions. Another really important benefit we get from microservices is independent scalability. So if we think back to the monolith, we were forced to make decisions very early, often when we knew the least. One of the most important questions that we would have to answer on a beginning project was, how much capacity would you say you're going to need? And there's only one answer we could legitimately give, and that's, I have no idea. And so what would we do? We would have to come up with a swag. We'd have to say, all right, take my worst case, let's double that, let's add another 50%, and you know what, let's just double it again, because I might need it. And it's so much easier to have it and not need it than need it and have to go back and ask for it later. Because my experience in enterprise IT tells me it always takes weeks or months to get any request done, and it requires lots and lots of tickets. The ticketing system in most companies, I think, is actually designed to make sure you don't ask for anything, because you can't possibly fill the tickets out correctly. The only luck I ever had was, hey, you got one of these to work, right? Can I see it? And then I would copy it and then make a few changes. That's the only way you could ever get a ticket to work. And it inevitably meant I had to go to lots of meetings and send lots of email and then go track people down. And so it was very much in our best interest to heavily over-allocate our resources. Because again, better to have it and not need it than try to get something added later. Which meant in almost all companies, we were dealing with single-digit resource utilization, which we probably didn't mind because it wasn't literally coming out of our paycheck. But I assure you, our customers probably weren't real happy about spending all this extra money on capacity they weren't using. Now, I've had some people tell me, oh, I don't care about the cloud because, my traffic is super predictable. Well, that's not always the case. We have these situations now where unexpected demand happens. You can plan for marketing has this big idea, we know we're going to need capacity, or we're doing this new push, that's going to happen in this month, so we need to have capacity. But look at the world we live in today. All it takes is somebody tweets something out or puts something on Instagram, and all of a sudden your traffic quadruples in minutes. I felt bad for operations staff because the annual budget process was just as painful for them as it is for us. It's really difficult to smoothly add capacity when these things don't always happen in nice, smooth circles. So cloud environments, microservices say we don't have to do that anymore. I can add and remove capacity on demand. I can actually wait till I know more. I can wait for that last responsible moment. I don't have to guess. And so the monolith implied a lot of this, because when I came to the monolith and I said, I want to scale it up, I have to scale the whole thing. It was this all or nothing proposition, which meant, again, I needed a lot more capacity than I really needed. So if we think back to that widget.io example, there's a pretty good chance order processing might scale more uniquely than the rest of the system. So if I pull that out, I can scale that as necessary. I'm not forced to go through that one-size-fits-all mantra again. One of the outcomes of this is I can now fully utilize my compute. I don't have to sit there and have a whole bunch of servers idle. Now that does, of course, lead us to an interesting question, which is, what needs capacity? How do I find these aspects of my system? Well, that's where we look at monitoring. A lot of people don't fully grasp that when you get into a microservices ecosystem, monitoring becomes your friend. If you're doing this at scale, I highly recommend that you familiarize yourself with the SRE book from Google. This is not something you need to read cover to cover. It's a series of essays that are roughly grouped in sort of thematic aspects. You can read one, put it down for a week, read another one, put it down for a month, read another one. Again, do not have to read it cover to cover. You can if you want to. But one of the things they talk about in the SRE book are the 4 golden signals. So we can look at latency. How long does it take to service a request? We can look at our traffic rates. What's the demand on this system? What are requests per second? What's our I/O rate? We can look at errors. How many failed requests did we have? We can look at saturation of a constrained resource. It's very important to understand your sampling frequency. So many of us are like, higher's always better. It's not. We might not be getting more meaningful data, and it might just be really expensive. So in a lot of cases, aggregation is your friend. There's a ton of tools in this space. If you're doing Spring Boot, you can let Actuator tell you an awful lot about what's going on with your system. Don't be afraid to start there and just say, hey, what am I getting for free if I'm using Spring Boot? Now, I want to stress, it takes some time to figure this out. This is not, obvious to all of us immediately. You're going to have to play with your system for a bit to kind of figure some of these out. This is part of the reason why more and more companies are spinning up SRE groups. Be very, very cautious on metrics that are easy to measure, that may or may not be useful to you. The other part of this that can be really challenging is we have to have conversations with our business partners to understand what are the business drivers on this system. What could happen that would cause a big spike in demand, and how does that translate to the services that I've written? It's really, really important that we be realistic here. A lot of times our customers are overly optimistic. We're going to take over the world. We can't all be a third of internet traffic. I'm sorry, that's just not how it works. So be realistic. Again, independent scalability is a massive, massive win of microservices, assuming you need it. The next thing we can look at is failure isolation. So one of the things that becomes very obvious when you get into a microservices biome is none of these are an island. They have to work together to accomplish something. And this is where you start to think, about Obi-Wan. You've taken your first step into a larger world. So no service works alone. That should be obvious based on the name. Now, integrations have been around forever. Often in our industry, it's baling twine and duct tape. I think my favorite scene from that Apollo 13 movie is when they realize the carbon dioxide filters aren't going to work for that many astronauts, and so they go in this room and they dump a bunch of stuff out on the table and say, we got to make this fit into this using nothing but this. We do this too. Not with the life criticality part generally. We end up dealing with a lot of third-party things. They may or may not meet our SLOs. They're going to fail. Failures find a way. Now, unfortunately for us, our customers don't care why it failed. So we can use microservices to help isolate this. And there's a decent chance you already know where the problem children are in your code base. But don't be afraid to do an architectural review. Don't be afraid to get people together to look for failure points. It's not hard. Draw the architecture up on the board and ask impertinent questions. Ask, what happens if this fails? You know what I hear a lot? Oh, that can't fail. Yes, it can. Of course it can. We need to think through how our service could fail. We need to think through what would happen in this weird one-off case. And it's hard. We're really good at happy path. We're not so good at unhappy path. Several years ago, I came to the office one random Tuesday morning, and my director came over to me and said, hey, you worked on this system 6 months ago, right? I'm like, yes, I did. Well, they had a build break this morning. Can you look into it? And I said, well, sure, but if they had a build break, it's probably related to whatever they just changed. And he said, I know that. And I said that to them, and they said, we haven't actually changed code in a week. I'm like, well, that's weird. If they haven't changed anything, how can anything break? So I looked into the code, and I realized, this test failed. Let's see what's going on. Oh, it was a test that I'd written. And as I looked more closely, I realized this test is going to fail every 7 years. There's just some random date thing, and it just happened to fail on that Tuesday. And for the life of me, I can't remember what I did to fix it. I may have literally just said, this will pass tomorrow. I don't know. It's hard for us to think about the road less traveled, but we have to. So we have to think about what are our systems talking to? How do they integrate? Is it a direct call? Is it through a proxy? What are our SLOs? Now here's something that I've found an awful lot. We generally don't have the same understanding of the system. There's almost always knowledge gaps, and that's okay. We need to understand these failure cases, and then we need to think through, all right, what do we do about it? How should we react? What's the appropriate reaction? Is it an error message? Is it to call a backup service? Is it to return a cached result? Is it to return a default answer? Now, the longer I've done this, the more convinced I am that there's 3 answers that work in all situations. You can throw 42 out to see who's read Hitchhiker's Guide. You can say another layer of indirection. That's one of my favorite things as an architect. But the answer I give more often than not is it depends. Because we have to think through what is the right response in this situation. And we're probably going to rely on the circuit breaker pattern. That looks a little bit something like this. So the circuit breaker sits there, it watches the call. It says, wait, I've exceeded my failure threshold. I'm going to open the circuit. I'm going to prevent calls from going through to this clearly distressed resource. I'm going to redirect to whatever my fallback mechanism happens to be. And I'm going to periodically recheck to see if things have been repaired. If so, we're going to go ahead and close the circuit. Now, the moral of the story is you cannot think of everything. Do not be afraid to introduce a little bit of chaos into your world. There is a reason why Netflix is so solid. Part of it is solid chaos engineering. Now, very closely related to this is indirection layers. So this is, again, a pattern that I use often. You probably do as well. It's another layer of indirection, and admittedly, it can be overkill. I think on every application I've ever worked on, we always had a data layer so that we could swap out the database. And yet, we almost never do that. It is the same basic concept as isolation with a bit of a twist. Now we're trying to protect our services from the things that change or things that are complicated to use. This could be a vendor dependency. It could be something big like an ERP system. It could be something simpler like a kind of currency conversion kind of thing. And so we're trying to isolate the things from change from others so that if we need to swap it out, we don't have to update everybody. It's just the proxy pattern. It can also be an adapter. So I'm traveling over here from the US, so I have US plugs. I need something that makes them fit in an EU outlet. No big deal. Sometimes this can be really useful as a way of simplifying an interaction. So we have a lot of situations where we have these third-party dependencies, and a lot of the things that are part of that might not matter to us at all. And so we can use the microservice to facade over that interaction to simplify it. It's just a typical gang of 4 pattern. So we can supply some context. Maybe your payment gateway needs your corporate headquarters address. You need an authorization token. That's not going to change in every call. You don't want every client to have to be aware of that. So we can actually bury that into that facade. And maybe you want to do a little bit of behavior before or after the calls. Again, that indirection layer gives us a really natural spot for that. Now, architecture is often defined as the things that are hard to change or the things we wish we'd gotten right. And of course, we all realize things are going to change, which is where we have to say, isn't this kind of anti-agile? And I think this is at least part of the reason why a number of people have said architecture is anti-agile, or we don't need architects, we're agile. Now, the reality is you have people making architectural decisions on your projects regardless of title, regardless of role. I hope they're making good ones. You'll know in a year or two. If they're not, you end up in a situation like this where, oh, hey, our app's got a whole bunch of different UI frameworks in it. I wonder how that happened. So how do we react to that? Well, maybe we change our assumptions. Maybe we decide architecture should be designed to change. That's the core tenet of this book, which says we expect an architecture to support guided incremental change. Microservices help here. They give us some additional flexibility. Now, inevitably, one of the reasons I see people leap towards microservices is polyglot. People are so excited about finally getting to use that language or framework or database that they've been dying to put on their resume. I have to be very cautious with this one. That siren song can be dangerous. Monoliths forced us to standardize as an organization, and I've been in a lot of companies where we literally define ourselves by their tech stack. We're a Java shop, we're a .NET shop, we're a Ruby shop. And that basically translates to, I have a hammer, somebody please bring me a problem. Now, there are positives to this approach. If we have standardized on one language, we are developing some deep expertise. It can be easier to shift people either just to cross-pollinate or as workloads shift. It can simplify hiring. It can simplify training. Although in fairness, and I know I said a little about this yesterday, the way we interview, I think, is really challenging in this industry. We get so fixated on this like checkbox of skills that we lose sight of the fact that we can all learn new things. And I can teach you what you need to know, because the reality is, a year from now, 5 years from now, we're probably not going to be working with the exact same technologies we are today. So why should I get so fixated on, do you know this specific thing today? None of us knew how to program a computer when we were born. Every single one of us learned the first language. And if you learn the first one, you can learn the second, the third, the fourth, the fifth. It gets easier the more you learn. Certainly it was better for operations people. They could focus on only one kind of environment, a lot easier to stand that up. But let's be honest, as soon as you get practically beyond one or two teams, one size does not fit all. You are going to have different needs, and that's okay. Now, there are downsides to this approach. Whenever I've been in these environments, currency was always constrained by whoever the slowest moving application was. You've all been in that situation where like, I really want to upgrade to the next version of Java or .NET or Node or whatever it happens to be, and you're told, I'm sorry, you can't have that yet. You can't have nice things because we have this really old legacy application, or if you want to be positive, heritage application, that's not ready. And you've probably been in a situation where by the time we actually upgrade, the new version is actually outdated. I was talking to somebody about this earlier this year, and they said this was a very classic pattern for them. Their infrastructure people would settle on, okay, this is what we're going to move to, and basically by the time that got to like test or maint or pre-pod or staging, whatever you call it, that version would already be end of life. It took so long to move things through their region. Now, I've yet to be in a company that's truly homogeneous. We just do one thing and only one thing. All it takes is one merger, one acquisition, and boom, you've got a whole nother tech stack to deal with. And believe me, there is no compelling reason to rewrite from one language to another short of this language is end of life. I've been involved in these debates. I had somebody try to convince me that, well, now that we're merging with a company that does .NET, we're going to rewrite all of the Java apps as .NET. Now think about how I'm supposed to pitch this to a customer. All right, so we're going to take your Java app that's been functioning just fine, and we're going to rewrite it into C#. Why is that? Because, okay, well, I'm going to get lots of new features, right? Actually, no, we're going to have to really constrain scope just to get this done in any reasonable amount of time. Okay, but it's going to be done quickly, right? You guys can do this in a few weeks, maybe a couple months. No, it's probably going to take us, 18 months, 2 years. Oh, well, there'll be fewer defects, right? No, actually, we're probably going to put a whole bunch of new ones in there because we don't really understand how the old system works. Great, get out of my office, don't ever come back. I can't make that pitch. Nor should I. It's not reasonable. Now, one thing that's changed is these cloud environments have actually removed that constraint. I'm not stuck in this model of that's what my operations people know how to support. I actually can easily spin up different stacks. So this notion of polyglot isn't just a pipe dream anymore. But I have to stress, these are just tools. That's it. The challenge for us is knowing when to apply that tool. When is the right time to reach for a sledgehammer? When is the right time to reach for a framing hammer? When is the right time to reach for a finishing hammer? And that, to me, is the real challenge. We have this tendency to glom onto one tool and say, this is the answer to solve all my problems. You would never accept that. If you had someone come do some construction in your house, you'd never accept somebody that shows up and says, I use a sledgehammer for everything. You'd ask them to leave. We should be the same way. We should be picking the right tools for the job. Now, one of the things that's very handy about this is I'm no longer forced to put a square peg into a round hole and just hit it harder. But, and there is always a but, we need to be very cautious about technical sprawl. And a lot of people look at Polyglot and they're like, oh, this is fantastic. Everybody can use anything they want. They can all pick the right tool for the job. But here's the reality. A lot of what people say is the right tool for the job is just their favorite thing. And so before you know it, you have so many different ways of doing the same thing. Everybody's got their own pipeline preferences. Everyone's got their own metrics. And now there isn't just one or two or three paths, there's dozens. How do we staff up in this environment? I know there's this talk today about full stack developer. I'm not a big fan of that terminology because I just don't think it's reasonable to say you need to be an expert on 3 or 4 front-end frameworks, 4 or 5 back-end languages, a bunch of different databases, and that's before we even start talking about cloud environments and CI/CD and testing and all these other things. How can one human being be an expert on that much? I just don't think that's reasonable. So how do we hire for these situations? There's a decent chance you've had this experience. Somebody in your company got really fired up about a language, Go or Ruby or something, and they wrote an application in it, and then they left. And you just look at that and you're like, we have no idea how to maintain this. And then you think about how many things you have to layer on top of that. And you have to think about currency. Currency matters today. The Equifax hack got a lot of people's attention. And amazingly enough, that software is still widely used. But these hacks are getting bigger and bigger and bigger. So it can't be a free-for-all. You're going to need some guardrails. So some companies have standardized and said you can use anything you want as long as it's on the JVM. My previous organization, we basically had 3 flavors. And part of my job as an architect, if you came to me and wanted something other than that, was to tell you no. Now, we'd listen, obviously, if you had good, compelling reasons, we'd work with you. But in general, our job was to send you down one of these paved roads. Again, that's what's typically being done here. This is a well-worn path. We know how to support it. Work with that. Minimum maintenance road, you are on your own. You are accountable. You are responsible. You build it, you own it. And by the way, that also means if you made a bad technical choice, and 3 or 4 months later, we might have to have a really uncomfortable conversation about your bad technology choice. We need to understand that sprawl has a tendency to exacerbate technical debt. This, again, is why we need to focus on the micro part of microservices. They are supposed to be small. Now, we can have a debate about that from now until the end of time. Again, in my estimation, this 2 weeks or less is a nice place to start, because if we chose poorly, we lost an iteration. I can recover from that. If I spend more time than that, I become more invested, and I'm more resistant to change, even if change is the right thing to do. So if we've got 6 months down this rabbit hole, we're really resistant to make changes, even if that's the right answer. So yes, microservices allow us to choose the right technology for the job. We have to make sure that we're doing the due diligence to weigh the pros and cons of that decision and understand that with great power comes great responsibility. And I'm going to say it again, you build it, you own it, you run it. Vital that we resist the temptation to perform resume-driven design. We've all done it. It's okay, but we just need to think through, is that why I'm trying to do this? So to wrap this up, microservices, we get some really impressive benefits here. They do not come for free. I strongly, strongly advise you, if you are going to pay that complexity tax, make sure you're getting something in return for that. So no, not everything needs to be a microservice. Please use them where they make sense. Please use them where they add value. If you look at the principles I've laid out today and you need one or more of them, great, go forth and prosper. If not, don't worry, you can just use serverless, it'll all work out in the end. Folks, thank you so much. I really appreciate your time and attention today. I'll be milling about if you have questions, but I hope you enjoy the rest of your day. Thank you.